Alright guys, so today we are still continuation on that video, the one I dropped previously. So we are still on algebra. Introduction to sets. What is set? Look at the board clearly. If you are asked what set is, nobody will ask you the question, obviously. It can only come out in your OBJ. And theoretically no one will ask you. So set is defined as what? As a collection of well-defined objects. Collection of well-defined objects. What are those well-defined objects? Objects with meaning. Objects with meaning. Those are what we call well-defined objects. Alright. We now have types of sets. We have what? We have types of sets. So when you're talking about types of sets, and don't get me wrong, there's a difference between when you ask types of sets and operations of sets. You have, those operations are those symbols you use in the set of natural numbers, set of rational, set of irrational, all this stuff. But when you ask types of sets, these are what we call types of sets. So types of set now, we have the empty set, we have the singleton set, we have the finite set, we have the infinite set, we have the equal set, we have the equivalent set, we have the subset, we have the power set, we have the universal set, we have the disjoint set, we have the union of set, then we have the intersection of sets, then we have complement of a set. So now I am going to break it one after the other, and I want your attention. You understand? Don't worry, most of you are panicking about Venn diagram. Venn diagram is the smallest thing. You understand? We are going to do the one of 2-dimensional and 3-dimensional. But let us take it step by step. And I bet you at the end of this video, it's going to be a congratulation. And you are going to love it very hard. Okay, so let us start with an empty set. So what is an empty set? Okay. Let me start with what empty set is. So mind you, whenever you hear the word set is always denoted with a capital letter, while the element, or which we call the member, is always denoted with small letters. So if I have A, I have capital letter A, I have small letter A. The difference between this and this is that this is a set and this is an element. So element is a member of a set. Element is defined as what? As a member of a set. Do you understand now? So that's it. And we have different kind of brackets because we are going to be introducing, there's a particular bracket we use mostly in sets. We call it a curly bracket. This kind of bracket is called curly bracket. You understand? So we have this type of bracket too. This kind of bracket is called open bracket. Then we also have this kind of bracket. This kind of bracket is called what? A closed bracket. But most times we use this curly bracket in your set. Alright, let me just say virtually in all algebra courses, real analysis, metric space, what else do we have? Groups and range, functional analysis, all those things like that. Only mathematics students can relate with that. Alright, so anyways, so now let's deal with empty sets. Now, empty set, this is a set, or this, let me just say these are sets with no element or members. These are elements. These are sets with no element or member. For instance, let me give you, for example, if we are told to give an example of an empty set, let me just say, human being without head. Obviously, it's an empty set. So since when I've been better, I've never seen a human being without head. Virtually all human beings have head. The only thing you can say is that some are deformed, some are complete. But particularly having head, all human beings have head. So human being without head, birth without head is an empty set, obviously. Is that clear? Alright. That's an example of empty set. That's what they are said that has no element at all. Like it can also be called a what? A known set. That's another name we can call our empty set. So it is denoted by it is denoted by just this curly bracket with nothing inside. So this is the symbol. So for instance, you are finding something, maybe the intersection between something is not, there's don't have any intersection, so the intersection there is empty. You just put this back. When a set is empty, this is what you leave, which is what you write it down. It's not as if you are writing a number. This is just what you are going to write. It is denoted by this, or it is also denoted by this symbol. You can leave this symbol as it, or you can even use file. You understand? So you can use file to represent your empty set. So that's the denotation. Anyway, so let's get down to singleton set. Singleton set. So these are sets with, or let me just say, sorry, let me use this. This is a set with just one element. With just one element. Set with just an element. With just an element is what we call singleton. That's just one element. For instance, the president of Nigeria. The president of Nigeria is a singleton set. Nigeria as a whole is a universal set. So the president of Nigeria is a singleton set because it's having one element. So we don't use to have, apart from, okay, let's say, okay, president of Nigeria is there. We don't have used to have the president. The only thing is you can have president, vice president, but president as just the title. You can't have it to be double. Okay, so or we can say governor of Oyo State. So you can just have only single one. Okay, so that's it. All right, so. Anyway, let me just give you an example. Suppose S equals to this. So set X is a singleton set because it is having one element in it. So that is it. So what is a finite set? Let's come to a finite set. So when we want to talk about a finite set, no stress. Now, this is a set in which its element is countable. So a set in which its element is countable is what we call a finite set. You understand? For instance, we can count beans, e.g. you can count beans. What else you can? Sachet water. You can count, let me just say, O number less than 10. O number less than 10. So if you have O number less than 10, that's 0, 1. Okay. And let me just suggest another thing. Or even number less than 12. 2, 4, 6, less than 12, 8, 10. So you can count everything that is there. So it is a finite set. Something you can count is what we call finite. Infinite is something that is uncountable, e.g. water. So do I really need to explain what infinite is? So infinite set is an opposite of this. So finite set is a set in which its elements can be counted. As I can suggest, you can use samples all around to make an illustration. So that's, you can count the governor of a state, you can count the honorable of a state, you can count the number of students in your department. So the number of students in the mathematics department, it is a finite set. Alright, so that's that. So the opposite of it is infinite. So equal sets. So for instance, when you're talking about equal set, so when you talk about equal set, so when the element in set A is same as element in set B, regardless of its order, is said to be an equal set. E.g., if, let's suppose that if A is equals to IJKL, I'm using a curly bracket, and B is equals to JIKL. So you can see, if you look at it very well, the same thing you have here, the same thing you have here. So regardless of the element of the order, so A and B are equal sets. So I believe you understand what I mean by equal set. So you mathematically, you can express it as set A is equal to set what? B. So simple as that. So if it's not equal, you just cross this. But so far it is equal, then you just put this. So that's the final answer about that. So I'm going to go to equivalent set. So what some of you may be looking like, some of you you'll be like, you have equal set, you have equivalent set. What's not the difference? There is a slight difference there, so no stress. So I'm going to be rubbing off this. So I'm going to be rubbing it off. I'm going to be rubbing it off. Okay. Set is stressful. Like it's a long walk. Alright. So equivalent set. Two sets A and B. You can suggest P and Q, anything you can use to make your set, it doesn't matter. You said A and B are said to be equivalent if they both are having same number of elements in them. E.g., if I'm having that A is equals to 1, 2, 3, 4, and I'm having that B is equals to 5, 6, 7, 8. Let me just suggest. So you can see clearly that A is equivalent. A is equivalent to what? Is equivalent to B. So they are equivalent sets because the element 1 be 1, 2, 3, 4, 1, 2, 3, 4. So they are having the same number of sets. So that's what we call an equivalent set. So no stress. So let's get down to subset. Alright, subset. Now, subset. Now, let me say A is said to be a subset of B. I'm just trying to use all these figures so you can understand. And on your own side, you can be like P is said to be a subset of Q. If and only if IFF means if and only if. It's just an abbreviation. The term IFF means what? If and only if. If and only if the element of set A is contained in set B. So another one is that it is denoted, the symbol for subset, it is denoted by this. So this is the symbol for subset. Okay, so now suppose that I want to give you an example. Suppose that A is having A, B, C, D, and B is having A, B, C, D, E, F, right? Alright, so what can you notice? You will notice that all the elements in this set A, you can find everything inside this place. So for the fact that you can find everything inside this place, like all the elements that this set A have, you can find everything inside this place. So it's so saying that hence it's so saying that A is a subset of what? Of B, because you can find all the elements that A has, but everything, you can find everything inside this place. So that's what makes it a subset of B. Do you get it? So in the Venn diagram format, you see you can write it like this. Since we can find all the elements of A in B, it means that the set A is all in B. So this is, you can see that the circle of the B is bigger because all the elements inside this place, you can find it inside this B. Do you understand? That is, I can express it like that: A, B, C, D. Then the rest can be around the circle, maybe E, F. If I remove this circle away, you see that the remaining of this thing is inside B, which means all the elements of this A, you can find it inside this, so no stress. Alright, so we can proceed. Now we are going to do superset. So sorry, I didn't add it up. Okay, I didn't add up superset in the types of set. Superset. Okay. Let me just be like, let me use another thing this time around. Let me just use mu is said to be a superset of, let's suggest another set, or set Q, if and only if mu, let me say set mu contained all elements of Q. So like this, the set of this one is contain all the elements of this. That is why it's a superset. But it's a different. You see, the words are different. If you say that this one, the element of this one is all contained in this, is a subset. But if you say that this element too, if you say that this set too, it contains all the elements that one has. I contain, this is Mr. Musa, this is Elite. So everything I have, like everything Mr. Musa is having, I have everything Mr. Musa is having, and even more. But a situation about you want to talk about Musa. Now it is, I'm talking about me, so I should be the one first. But if I'm talking about Musa, so that means Musa, things that Musa have is contained in me myself, so that's a subset. But from the other, you are talking about me, which is the superset. So I'm not the boss here, so it means, so let me add bossy. It means that I have everything. It means I have everything that Musa have, and even more. So that's a superset. So now, so if N is said to be a superset of what? Of set Q, if and only if set N contained all the elements of, that is, for instance, let's suppose that all O numbers, this one is O numbers, let me just say all O numbers. So now let me just say that Q is 1, 3, 4, 5, 6. So if you say all number, if this one even have more, it has all the elements that this one has. This one has everything. So it is saying that this one is a superset of what? Of Q. Because the symbol for superset is the opposite of this symbol. This is the symbol for superset. So take note of that clearly. No stress. Okay, so we are going to be doing, and see, it's a whole lot of work. It's a whole lot of work. Alright, so we are going to be doing, what's it called now? Power sets. Or before we do power set, let's jump to union and intersection, so it can save us time. So, or universal set precisely. Let me start with universal set. So contains contains overall elements. Contains overall elements as tens all other contains overall element as tens all other sets. So it can be represented by, you can use this long U, and you can use this, and you can also use nil to represent it. These three symbols, any of the two, you can use it. So you can use set of integers, positive and negative numbers. So that set of integers, you can use that can be your universal set, and you can use anything, all numbers, odd numbers, or blah blah blah, depending on where you are solving from. You get. So alright, so let me get on to union of sets. Union of sets. Sets A and B are said to be unioned if and only if all elements in both A and B are combined and arranged in order with no repetition. You should get that statement. Very simple. So for instance, let A to be equals to let A to be equals to 1, 2, 1, 3, 4, 6, and let B to be equals to 4, 1, 7, 8, 9. So our A union B will now be, now we have our A union B. Any element you can notice in this A and B, in this A and B, like this is a set A, this is set B, you can see there are some numbers that are repeating themselves. Any element you can notice in the whole of this, you can notice that there's 1, there's 2, there's 3, there's 4, there's 7, there's 8, there's 9. So but any element you can notice it in these both elements, you will list them out. So but while listing them out, make sure that you follow the numbering order. So and at the same time, while following the numbering order, if you notice that anyone is repeating itself, once you have picked it, you don't need to rewrite it again because it's repeating itself. Don't repeat anything. Anything you can observe, you are just bringing out the observable element there. What you can observe there and arranging it in both sets. 1, arranging it under, what do we have again? 2, what do we have here again? 3, don't repeat because they are repeating. What do you have in both sides again? 4, 6, 7, 8, 9. 7, 8, 9. Simple. So that's what we can notice in the whole of this set. So no, don't need to repeat anything. No, don't need to repeat anything. Don't repeat it. Okay. So that's it. So intersection of a set. Alright. That's what I said. Set A and B is said to have intersection if there exists between the two sets some, or let's just say a or some common elements. Like when they are having common elements, when set A and B are having common elements, it is called intersection. For instance, let A is equals to A, B, C, D, E. and let B to be equal to I, J, A, C, F. So what is the intersection between them? A intersection B. What would be A intersection B? Because this is a symbol for intersection. So what do they have in common? Make sure you follow the alphabetical order. What do they have in common? You can notice that they have A and C in common. So this is the intersection. No stress. Alright. So we are done. So what's complement of a set? Then I'll end it up with the power set. Complement of a set. So A prime is said to be a complement of A if and only if we required the elements remaining to complete the universal set. So example, okay, suppose that the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and our set is even number. Okay, then let me use that one. Let me use 4, 5, 7, 9. So find complement of A, that's A prime. I call it A prime. So look at the universal set and look at the complement of, and look at the universal set, look at test A. Is there to find complement of A. So look at it very well. This is universal set, this is A. So what element is remaining for A to meet up with this universal set? You can see that this one is not up to this. So the element that is remaining to make up with this is what we call complement of A. Do you get it now? So let's look at the element that this one has that this does not have. The element remaining for this one to complete the universal set. That the word complement is got from complete. So A prime is now going to be, what element is remaining? Accordingly, let's arrange it. It remains 1 for this one to complete is 1, 2, 3, 6, 8. What else again? I think that's all. So this is the element is remaining for this A to complete this one. So we have analyzed it out. So that's all about complement of the set. So I just want, we are doing introduction. Later we'll still solve some crazy questions, but not today. Maybe in my next video. Alright, so and lastly, okay, sorry, a disjoint set. Okay, let me save this one. What's power set? Let P of X be a representation of a what? A power set. Then power set P of X is divided by P of X is equal to 2 raised to power n. So where m represents highest power. Alright, so let me give the last example for today. Suppose that x1 substitute 1 it gives us A, comma B. Find power set solution. Alright, so we are giving this element now. This is set, we want to find the power set. How do you find the power set? But let's approach these formulas first. How many elements do we have here? The number of elements is 1, 2. We are having 2. So the cardinality of this power set is equal to 2 raised to power n, which is equal to 2 raised to power what? 2 equals to 4. So it implies that all the elements we must get for the power set at the end of the day must be 4. Okay, let's get that power set of this given set. So you have to start with, this is how you start. You start with empty set. That will be the first one. The first thing is that you start with empty set, comma. And after you start with empty set, you now start with single. You start with this, you identify it differentially. So you separate it first. After you separate it, you now start combining it. A, comma B. You promote it. So you can see that this is the power set of this set. So let me do another example. This is power set, very simple. So after doing it separately, then you end it up with this one. So another example. Okay. Example 2. If x2 is equal to a, comma b, comma c. So find px2 solution. What will be our px2? Our px2 will be, but we know already that everything inside will be 8. How? 2 raised to power n, 2 raised to power 3, 8. So everything that should be here should be 8. So that will be, let's start with empty set as usual. After that, you take it one after the other. A, comma B, comma what? C, comma, now I cannot pair 2, 2. Order of number now. A, comma B, this, A, comma C, what else? This one, this, then this one, this. B, comma C, then the 3, 1, 2, 3. A, B, C. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So that is what we call a power set. So I think I've been able to explain a lot of things here, so you don't have any issues. So there's something I did not touch. I'll just say with my mouth, cardinality of a set. So these are represent cardinality. If you say find cardinality of this set, so this is the symbol of cardinality when you back it up with this small letter n. So if I want to find cardinality of this set, I'll back it up with this. Then cardinality of this set is 1, 2, 3, 4, 5, 6, 7, 8. The number of elements a set contained. So just like there is what we call cardinality of a set. So please, I want you to take your time to study this video and take your time very well to study it. So my next video, I'm going to be solving series of examples on basically all these introductions. So this introduction is just to open your brain and open your eyes to see what you are in for and to get the basic knowledge. I love you guys. Don't forget to subscribe on my channel. Share this with your friends. Don't be selfish. Share it, let it go viral. I love you guys.